All right. As usual, I'm just going to go over this test. I do have a second version um, of these first couple of pages ready to go, so we can go over that as well. The proofs that were on the practice test are going to be the exact same that you will see on the test. So I'm not going to go over those, or at least I'm not going to do them. I'm willing to answer a couple of questions about it, but if I feel like I'm just going to end up doing the proof for you, I'll stop. Okay. Um, Keep in mind you can always post questions in the comments. I'll kind of read them periodically, or email me. It's probably harder to email me because I won't look at that constantly. Um, so comments is probably better. Keep in mind that there is like a 10-second delay in me talking and you actually hearing it. So if my question isn't answered immediately, just give me a couple of seconds to answer it. All right. Um, so first, we'll run through the entire first part of the test. If we need to, I'll bring out the second copy, um, and just go from there. Now, I did email you the answer key to this. So this is the exact same practice test you got in class. Um, it's the full version of it. I misprinted it in class, but this is the full version. All right. So we'll just go ahead and start working. Just gotta clean up a couple of things. All right. These first five all rely on definitions of classifying triangles by both angles and sides. So there's, I think, like in total 7 different definitions that we need to know. So we can classify it by angles and by sides. So we'll start with angles. Triangles can either be right, acute, obtuse, or equiangular. All of which we've gone over before. This is just kind of common sense stuff. Right triangles are always going to have a right angle in them, so kind of like number 2. Acute triangles will have all of their angles be acute. Obtuse triangles will have one obtuse triangle, and equiangular triangles will have all of their angles be equal. All right. So if we classify by sides, we can have scalene. Scalene triangles are triangles who none of their sides are congruent. We have isosceles. Isosceles triangles are triangles who has 2 sides that are congruent to one another. And then we have equilateral. And equilateral triangles are kind of like equiangular, except all of their sides are congruent. So all three sides of the triangle are congruent to one another. All right. So if we work through this, number one has 9.4 on each side, so it is equilateral. And it has 60 degrees for each angle, which means it is also equiangular. On the test, this answer is fine, except this also has another name. It's called regular, which we've also gone over before. So this is fine, but I will also take this. Number 2, none of the sides are congruent, so this will be scalene. And then there is a right angle right here, So this is a scalene right triangle. Number three. Number three has two sides that are congruent. So this is an isosceles triangle. And two angles that are congruent. But that doesn't matter. What matters is that each of these angles are acute. So this is an isosceles acute triangle, or an acute isosceles triangle. It doesn't matter which order. I just want you to be able to classify both. On number four, all of the angles are acute. And none of the sides are congruent to one another. So this is an acute scalene triangle. Number five, none of the two of the sides are congruent, so it's isosceles. And one of the angles is obtuse, so this is an isosceles obtuse triangle, or an obtuse isosceles triangle. Yes, for number one, you can just put regular. I'll take both of those answers. Regular is probably the better answer. But equilateral and equiangular is fine. A regular triangle is a triangle whose equilateral and equiangular. So both will do. I guess before we move on, questions on numbers 1 through 5. All right. You can still ask questions about 1 through 5. I'm just going to move on, and I'll get to those questions later. But for now, you can move on to 6, just the next part, I guess. All right. So 6 to looks like 10. I'll rely on your knowledge of the measures of interior angles of a triangle. All right. So we went over a theorem in class that says that the measures of the interior angles of a triangle all sum to 180. So if we have a triangle who has angles A, B, and C, A plus B plus C will always equal 180. Right? So we have to use this theorem and our knowledge of vertical angles, right angles, and all that, and linear pairs in order to solve for the question mark in each of the given triangles. Okay, so sometimes this requires a couple of steps, like on number 6. So number 6, we can't get this triangle right off the bat. We actually have to solve this triangle first. And in order to do that, we add the two angles that were given, so 55 and 65. That is equal to 120. So those two angles add up to 120. The three angles have to add up to 180. So we take 120 and subtract it from 180. That is equal to 60. So this angle right here is 60 degrees. Now, because that angle is 60, that means that this angle is also 60 because those are vertical angles. So now we have two angles in the triangle that we're trying to solve. So we can add 50 and 60 together. That's equal to 110. So if these two angles are add up to 110 and the entire triangle has to add up to 180, we subtract 110 from 180 to get 70, and 70 degrees is our answer. It's kind of the same process for number 7. The first thing we have to do is solve for this angle. So 50 plus 30, that is equal to 80 degrees. We know that all three of the angles have to add up to 180. So we'll call that angle X. So if we subtract 80 from both sides, we get X should equal 100. Which means that this angle is also equal to 100 because those are vertical angles. So now we have a 100-degree angle, a 40-degree angle, and some other angle, all three of which have to sum to 180. So 100 plus 40 plus our unknown should equal to 180. And then we just solve. On number 8, instead of vertical angles, we're actually using a linear pair. So in the triangle on the left, we need to solve that first. So 80 plus 23 plus our unknown, we'll call that X. So this angle right here should equal 180. So 103 plus X is equal to 80. So X will be 77. So this angle is 77 degrees. Now, instead of vertical angles here, we have to understand that the three angles, so this blue angle, this angle right here, and this angle all have to equal 180. And we have two of those, so we can solve for the third. So 77 plus 60 plus our other unknown, we'll call that purple angle Y, has to equal 180. And then we have to solve for Y. Yeah, that second line should equal 180. Sorry. Everything else is right, though. So if we solve for Y in this purple equation, 70 plus 60, that's 130, plus 7, that's 137. So 137 plus Y is equal to 180. And then Y then would equal 43. So now this purple angle is 43 degrees. And then we can solve this next triangle. So we have 43 and we have 27, and then we have an unknown. And we have to solve for that unknown. I'll do this in red. So 43 plus 27 plus our unknown has to equal 180. So 70 plus our unknown is equal to 180. Subtract 70 from both sides, so our unknown is 110. And number 9 is similar to numbers 6 and 7. The first thing we have to do is solve for this angle, use vertical angles, and then solve for the unknown. So if we do that, 35 plus 25 plus our unknown x is equal to 180. So 60 plus x is equal to 180. X is equal to 120. So both of those angles are equal to 120, and then we have to solve for unknown. So then 21 plus 120 is equal to our unknown. So 141, sorry, this is equal to 180. So before I move on to the next page, are there questions on number 6, 7, 8, or 9? All right. Number 10 is a lot like number 8. So the first thing we have to do is we have to solve for this angle, and then use what we know about straight angles to solve for this angle, and then solve for unknown. So we can add up the angles on the triangle to the left. We'll call our unknown here x, and the sum of those three angles has to equal 180. And we just solve for x. So then we have a 50-degree angle, a 74-degree angle, and some unknown angle. But all three of these angles add up to form a straight line, which is also equal to 180. So 50 plus 74 plus, we'll call this angle y, is going to equal 180. So 124 plus our unknown is equal to 180. So our unknown is equal to 56. And then we can use this 56-degree angle and this 24-degree angle to solve for our unknown. So we just add all three of those angles together. And solve. On number 6, yeah, that should be 60. 180 minus 120 is 60. Okay, now on numbers 11, onward, well, I guess 11, 12, and 13, we're using that same concept, but we're throwing in a variable and maybe a couple of right angles, right? So the same thing is still true. All three interior angles add up to 180, and we're just using that to solve for x. So on number 10, if we add up each of these angles, 42 plus 76 plus 11x minus 4, that has to equal 180. So then we can combine a couple of like terms. So 42 plus 76, that's 118. 118 minus 4, that's 114. So 114 plus 11x is equal to 180. If we subtract 114 from both sides, we get 11x is equal to 66. And then if we divide by 11 on both sides, we get x is just equal to 6. So on the test, will there be an x and a y in the same problem? I'm not going to specify x's and y's. I'm just naming these angles. So this angle and this angle. So it's a little bit easier to do here and here. Instead of having just a bunch of question marks, it's just easier to keep track of. You really don't even have to use this. You could just do 180 minus 74 minus 50. That'll get you the same thing. Or 180 minus 45 minus 85. It's going to get you the same thing. It's more of a concept thing. I'm just giving the angle the name. The solve for x problems should look like number 11 through 13. And if it didn't, instead of 45 degrees or instead of a question mark, it might be like 11x plus 3. I'm not going to give you those because I think if you understand this concept for 6 through 10, you understand that. Then we're just putting algebra to it, which is really what 11, 12, and 13 are doing, just in a little bit different of a way. But anyway, yeah, I mean, the test is still going to look like this, what I have up on screen. So I'm not going to change that right now. But moving on. Number 12. So we add these three angles together and set them equal to 180. All right, so 35 plus 90 plus 4x plus 15 is equal to 180. All right. You do have to know that this little square right here, that's a 90-degree angle. All right, so then we can combine like terms. So 125 plus 4x plus 15 is equal to 180. So 4x plus 140 is equal to 180. Subtract 140 from both sides, we get 4x is equal to 40. So x would equal 10. Number 13, you do the same thing. We just add those three angles together. So 4x plus 2 plus 90 plus 40 has to equal 180. So 4x plus 132 is equal to 180. So 4x will equal 48, and x will equal 12. Before we move on to theorems, are there questions about 11 through 12? All right. So numbers 14, 15, all the way to 19. Determine if the two triangles are congruent. If they are, state how you know. Right. So we've gone over 4 kind of major different theorems: side, 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 angle, side, angle, side, angle, and angle, angle, side. These are the reasons that 14 through 19 would be two pairs of congruent, or a pair of congruent triangles. So that's what I'm looking for. So for example, on number 14, we have two triangles. This side is congruent to this side. This angle is congruent to this angle. And this side is congruent to this side. So we have two sides and the included angle. So yes, these two triangles would be congruent. And the reason would be side, angle, side. Again, side, angle, and side. Number 15, kind of the same thing. We have an angle here, or sorry, a side here, a side, angle, angle. And then we have a side in common, so that's congruent to itself. All right, so on number 15, we have a side, an angle, and a side on both triangles. So yes, these would be congruent because of SAS. So Jack, I did problems 12 and 13, but I equaled them to 90 and still got 10 and 12. So the reason you're getting those right is because I'm guessing that you factored in that this is equal to 90. So then I'm going to do this off the page. So then you'd have 35 plus 4x plus 15 equals 180. No, sorry. Plus 90 would equal 180. So kind of. If you then just get rid of this 90 here, you get 35 plus 4x plus 15 is equal to 90. So I think this is probably where you started. I would rather you start from this step here, because that shows me that you know that the sum of all these angles add up to 180. So the reason that works is because you have a right angle inside it. If you didn't have a right angle inside it, then it wouldn't. So like, yeah, I would rather you start here, but I guess technically you did it right. All right, back on to 14 through 19. Number 16. So we have an angle congruent to another angle and a common side. So we have angle side, angle, angle, and side. But we don't have a third thing, so we can't know that these two triangles are congruent. They might be, but we can't prove it. So no, that's not necessarily congruent. Number 17, we have a side congruent to another side. We have another side congruent to another. So we have two sides, but we're not really given any angles. But we should know that this angle will be congruent to this angle because they are vertical. So since we have that, we have a side, an angle, and a side, an angle, and a side. So yes, these would be congruent because of SAS. Number 18, we have two sides and an angle. But that's not one of our theorems. So we have S, S, A, and S, S, A. And yeah, I'm aware that you could put those in a different order. There is an actual theorem for that. It's called HL, but we did not learn it, nor are we. So for your sake, for this test, these two triangles cannot be proven congruent. So the answer to this would just be no, not congruent. Number 19, we have an angle congruent to another angle. And then these two angles congruent. And a shared side. So that's congruent to itself. So we have angle, angle, side, angle, angle, side. So yes, these two would be congruent because of AAS. So 17, you're given two sides and an interior angle. So two consecutive sides and an interior angle on number 17. All right, number 18, you're given two sides and a non-included angle. It's not because of the right angle. It's just this angle is not included in these two sides. Same here. This angle isn't included in these two sides. If they were, so if this angle were up here and this angle were down here, then it would just be SAS again. But they're not, so we can't prove anything. All right. That's the entire like concept part of the test. And then you have the three proofs. All right. Again, I'm not going to do those for you because those are going to be the same proofs on the test tomorrow. But are there any other questions for this practice test or about tomorrow? Sam, what is your question on the third proof? We'll start there, and then Dominic, I'll get you. Um, can't W and A be a part of midpoint instead of just Y so we can figure out both angles, both triangles? No. Short answer. I'm not just blanking out. I'm trying to think about it because I'm looking at it right now. Just give me a second. Yeah, give me like 2 seconds. I'm still looking at this. I did it before I printed it. I'm just trying to figure out where I went wrong on this one. Okay. So number 22, if it's out in front of you. If not, here it is. Whoop. Number 22. I think I am missing part of the given there. Um, what I will probably put on the test, if I can write on this, I can't. So I'll write over here. I think what's missing is VW. Hold on. VW is congruent to VA. So given that little piece, you should be able to prove that the two smaller triangles are congruent, because that bigger triangle is an isosceles triangle. So you can use base angles theorem there and definition of midpoint, prove that the two smaller triangles are congruent, and then prove that WY is congruent to YA. I hope that makes sense. It's missing a little piece of information, which is this right here. Okay, so with that, you should be able to solve it. You know it's isosceles because we know that VX, so that left-hand side of the bigger triangle, is congruent to VZ. Which, because it's isosceles, also means something about the base angles as well. And with that base angle theorem and the midpoint and that little piece of information that I just gave you there, you can prove that the two smaller angles or triangles are congruent. And then WA or WY and W and YA would also be congruent. It might have been. This might be a little bit harder of a proof than I thought, but I'll give you that VW is congruent to VA. So yeah, I mean, I think number 20 and 21 are pretty straightforward. Um, Again, I did all these before I printed them and gave them to you, but regardless, some things that you will have to know for proofs that I think are fair game. Again, there's a lot of different ways to do those two proofs. Things that you need to know, though, are like definition of midpoint. All right angles are congruent. Base angle theorem. And then segment addition. Or subtraction, whatever you want to call it, that works. You also just like I'm not gonna put this on the list tomorrow. But this symbol that means perpendicular, which we've gone over, but I'm impressed by the number of people who keep asking me this. That means that two lines form a right angle, which means they form a 90-degree angle. And then, of course, you need to know, and the reason I gave you these proofs is because of SAS, SSS, ASA, and AAS, as well as CPCTC. So corresponding parts of congruent triangles are congruent. There shouldn't be a second C in there. CP, okay. CPCTC. Corresponding parts of congruent triangles are congruent. So if you ever prove that two triangles are congruent and you're trying to prove that another side that you didn't know is congruent, you would use that. Now, I'm going to give you an entire list of everything we've covered. So there'll be a lot more on it than this. It's like definition of vertical angles, the first 20 postulates, all the theorems. That'll all be on it. But you need to be able to pull out this kind of stuff. All right. Any other questions on the practice test? All right. I'm going on about an hour on here, so I'm gonna leave this open and put on some Zelda music, and just I'll be around for the next 10 or so minutes to answer questions. If nothing's happened in 10 minutes, I'll close it down. I will be in my room tomorrow by about 7:30. I might be there earlier. I might be there a couple minutes later, but I will be there about an hour before homeroom starts. So if you have questions, that would also be a great time. All right. So feel free to ask questions. I will gladly answer, but that's about all we wanted to go over. I can do another practice test. That's just going to take a bit of time. All right. So thank you. Yes, CBCTC will probably be used in number 20. Um, Starting 20, so there are two triangles there. I would try and prove that those two triangles are congruent and then see what you can do with that information. Um, that's this is going to be a lot like the ones on IXL. It just is a little bit more distorted. You're right. I You need to look at what's given and try and do what you can with two different triangles. Um, Two of those triangles share a common side. I would start there. Again, I'm not going to tell you specifically what triangles because I think that's fair game for you. But there are two triangles there. I would prove that they're congruent, and then you can get the third side. On number 21, nothing that's given says anything about midpoint. So all you're given is that angle ABC is 90 degrees and angle DCB is also 90 degrees. And then angle 1, so this smaller angle, is congruent to angle 2, also the smaller angle. If I were you, I would draw these two bigger triangles separately. That might help you. So I'll give another 2 minutes or so. Again, I will be there tomorrow morning and during activity period if people need me. So if there's any last second questions I can answer, go for it. Again, I will be there tomorrow morning. Um, Also, if you have any questions, you can always email me. So yeah, thank you for coming, and I will see you tomorrow.